Alright, back with Mr. Canada, and we're looking at higher roots. So when we're doing higher roots, we're solely going to look at the calculator method. And so this is where we use a symbol that sort of looks like this, okay? So it's going to have this little n value. Sometimes it shows it with just a little blank square, kind of there and there, right? That just tells us we can put in any value we want. So our root value is this n, and then our base number is, of course, always where we put the x or the a. So here, find the fourth root of 10,000. So as you can see, I am putting in a little 4 for that above the check mark, and then the 10,000 for the base. I'll get back the value of 10. Okay. Example 2, I am putting in for mine. I'm putting in 6, and in the inside 4,096, and that'll actually get back just an answer of 4. And lastly, I'm doing the exact same thing for the fourth power, or the fourth root of 2,401 is 7. You can tell how unused we really talk about these, because we just, after the squaring and cubing something, we just talk about the fourth, fifth, sixth powers. So here are 6 questions for you to try out. So pause the video, play around with the calculator, see what you get, and then we'll take up the answers in a bit. Okay, welcome back. So we're going to calculate these. So first off, we're doing the 37th root of 1. Well, that's always going to be 1. Here we have the fourth root of 625. That's 5. The fourth root of 81. That's 3. We're doing the 7th root of 64. And I'm going to guess that's 2, but I just have to check myself. And it's actually not. It is 1.81. So I was thinking maybe the 6th root. So the 2s are kind of easy because it's actually kind of, we end up using powers and stuff when we start talking about binary code and all that fun stuff. So here we're talking about the 5th root of 5. So what does a 5th root of the same number actually look like? Well, it's 1.38. So notice that we've really just start to approach our our 1 really, really slowly, right? So we're starting to approach 0 slowly. So you cannot take the square root of 0. So we always are just approaching that value. So we've dealt with these graphs before, and this is kind of why. So here we have the 4th root of, well, I am just going to count out the zeros as I put it in instead of saying it out. So we have 1, 1, 2, 3, 4, 5, 6, 7. So that is, I just want to recount that. So 1, 2, 3, 4, 5, 6, 7, and a 1. 1, 2, 3, 4, 5, 6, 7, and a 1. Yeah. So we end up getting an answer of 56.23. Okay. It's always good to check. I always tell my students, I've been doing this for years, and I still like to double check when I think that, hey, there's a possibility I could make a mistake here.